The question number 2 says a student investigated a ball bouncing from a slope. So basically, from an initial height, the ball will be bouncing to a slope, and then it will be bouncing again from the slope, and it will land somewhere right here or here or here. Okay. So basically, the question further says a student used a protractor to measure the angle theta of the slope to the horizontal. So basically, the angle of the height of the slope, or it is slanted, right? So this theta value, okay. She dropped the ball from the initial position shown. So this is the initial position from which the ball was dropped. She used a meter rule to measure the distance x. So the distance x is the position at which the ball was um, dropped and to the position it landed. So basically, this is the distance x, the position from where it bounced actually. After bouncing on the slope to the position it will bounce again, or it will fall, or it will land actually. This is the distance they're talking about. So she said she varied theta and measured corresponding values of x. This is quite obvious, right? If the slope was quite more like this, then if a ball bounced right here, it will be having a greater trajectory, right? It will land at a more further place, to the farthest, right? This is what they are talking about. Now state one control variable for this investigation. So basically, one thing that she will need to keep constant. Control variable means the variable which needs to be constant throughout the actually the variation that she's doing. She's varying the theta. She's varying the slope, the angle of the slope, and she's trying to get the value of x, I mean the distance to which the ball will land from the slope after bouncing. But one thing that she needs to control is the initial height of the ball. If you keep the initial height of the ball same, then you will be able to see how the x changes when the theta value is changing. But if you change the initial height from which the ball is falling, then you are basically making changes in all the three departments, and you will not be able to get the corresponding values of x with theta. So that's why you have to keep this value constant to get the corresponding x values with the change in theta when you will increase the value of this slope, or you will decrease the value of this slope. So this is what control variable is. And you can also keep another thing constant, which is the initial velocity of the ball. You will also have to keep the initial velocity of the ball constant. This is quite obvious, right? If the initial velocity is increased, then it will actually bounce with a greater kinetic energy, and when it will bounce with a greater kinetic energy, it will travel a greater trajectory. So we are not getting the x values solely depending on the theta values, right? This is the main reason why we will be keeping the initial velocity and the initial height constant for this variation of theta to get the corresponding values of x. Now this is actually the answer. You can write any either of them because the question was of 1 mark, but if it was 2 marks, then we could have written both of them. So you should keep both of them in your mind, so that whether in your exam day, if it is a 2 marks question, you can write them. Now the next question is said explain why it is necessary to control this variable. Here the question is 2 marks, and you always need to keep a close eye on the marks while solving physics exam questions, because every mark, according to every mark, you should give every point. So as there is 2 marks, you will have to give 2 points. Now it says explain why it is necessary to control this variable. Now we have explained that previously. If you have taken a greater height and you didn't keep the height same, then it would have a greater gravitational potential energy. So as it has a greater initial gravitational potential energy, it will land on the slope. It will land on the slope with a greater kinetic energy. Sorry, it will land on the slope on a greater kinetic energy, and it will bounce off the slope with a greater kinetic energy as well, right? If it has a greater gravitational potential energy, right here, while bouncing from the slope, it will have a greater kinetic energy. So the probability of it landing farthest to this position is greatest, and it's falling further away from this position is not dependent on the theta, it is dependent on the GP, but we want our x value to increase or decrease depending on the theta. So it is not solely depending on the theta, and that's why we are not getting the corresponding values of x for theta. That is the reason. Now another thing that we can consider is height affects the gravitational potential energy, and as the height affects the gravitational potential energy, that's why we'll have to keep the height the same. And why did we have to keep the initial velocity same? Because the impact velocity of the kinetic energy may vary if we don't keep the height the same. If we don't keep the height the same, the impact velocity of the kinetic energy may vary. The same thing that I have said, that if you increase the height, it will impact with the slope with a greater kinetic energy or with a greater velocity than it should be. So that's why we have to keep the control variable constant. And the control variable right here is the height from which the ball should be released. Now let's move forward to the next part of this question. The next part says, the student recorded the following data to plot a graph of theta against x. Now the question asks us to criticize the data. Now here, if we criticize the theta values, you can see not all of them are in the same significant figures, or their decimal places are not actually consistent. Here it is 2 decimal place. Here in 3 of them, they are not actually in the same decimal places. Okay, so we can say inconsistent decimal places, the first comment that I can do. Now the second comment that we can do is there is no repeat readings. They didn't repeat the theta values twice, any theta values twice. They have done all the theta values only once. They didn't repeat. Let's say you will repeat with 10 degree twice or thrice to see how the x is coming, to get a better value of x, to reduce the random errors, right? But they didn't repeat any theta values. They have done with different theta values every time. And the third criticize the third way I will criticize them is there is only 3 sets of data, and we need at least 5 or 6 sets of data to draw a graph, right? So basically this is very small sets of data that they have provided us with, or they have only calculated with only 3 different values of theta. They should have calculated with more different values of theta to be able to draw a reliable graph. And another way I will criticize them is, you can see for 10 degrees Celsius it was 35.8, and for 31 degrees Celsius it was 61. Both of them are quite close. So for 20.5 degrees it should have been between 35 and 61, right? But it is 592, which is way higher than the other two, right? So it is not following the trend of the other two. So that's why we can say these are the 4 ways we can actually criticize them. I have written 4 of them, but you will have to give only 3 of them because the question is a 3 marks question. The values of x and theta are not recorded to consistent decimal places. The decimal places are not consistent, they're inconsistent. There is no evidence of repeats. They didn't repeat the readings. There are not enough sets of data to draw a reliable graph. And the reading of x at 20 point degree doesn't follow the trends of the others. So these are the ways we will be criticizing this particular data provided by the student. Now let's move forward. Let's say what the next question says. In the next question, the student wrote a laboratory report about her investigation. She reported the most significant source of error was being unable to judge the exact point where the ball landed. This was because the ball moved too quickly. So basically, the problem that she was facing was to judge where actually this ball landed. This was the problem that she was having to judge, and just because of that she was having errors. Okay, she was making errors. This was a significant source of error, because if you cannot judge whether the ball is landing, you cannot figure out the value of x exactly, right? The correct value of x. Explain one modification she could make to the apparatus to reduce this error. Now, one thing that comes to my mind is, if she records the whole procedure, then it will be very easy to go through the video in slow motion to see where the ball was exactly landing, right? So she can use a camera to record the motion, which can be viewed in slow motion to find the exact point where the ball landed. Otherwise, we can also do another thing. That is, we can place a tray of sand right here. If we place a tray of sand right here, when the ball will come, the ball will hit the sand and it will stop right here. It will not move. So as it will not move, the sand on the, as it will not move after landing on the sand, we can get the exact point where it actually landed, and it will also put some indentation. Okay, so we can also see where the ball actually landed in the sand. So that in that manner we can actually figure out the value of x, and we can actually figure out at where the ball actually landed, exactly at what point the ball actually landed. So basically I have given you two different ways to answer this question. You can write either in this two way or in this two way. Any two answers will be correct. You can write either of them. Okay, either this one or this one. Both of them are exactly the correct answers. Hopefully you guys have understood this paper, and in the next video I'll be solving the question number 3 from the May 2024 Physics Unit 3. And please don't forget to subscribe my YouTube channel for more videos regarding physics, chemistry, biology, maths, economics, business, all A levels and O levels subjects of both Edexcel and Cambridge. And please comment down below the next paper on which you want us to make a video on, or any particular topic on which you want to make a video, so that you can understand that in a much better fashion. Don't forget to subscribe, comment, and share with your friends. Thank you guys. Bye bye for today.